Okay, what do I do now? Oh, you can have a point, Natalie. Thank you for handling that. I'm still putting in 30% grades, so if they don't do stuff, they just get bad grades and 30%.
What's this do?
The semester exam study guide, the day you take the semester exam. But I'm going to post the key.
Okay.
When you take the semester exam, was that your question?
I can see what you're talking about. Key up, so like completely just.
I mean, you're going to have it. I'm going to spot check it, but yeah, you're going to have it completely right, Cameron, because, again, you're going to have all the answers.
Because I didn't know if she was going to finish it.
I am. Well, I might not. Even the ones we don't finish in class, I'll post my like handwriting key. You can do what Seth does. He literally prints it out and like. I don't know if you do that or not, and then sit it beside there. I don't.
No, I'm the only one that do that.
Okay, what do I do now?
Just 5.
How do I get rid of that square root? What do I do to both sides to get rid of the square roots? Oh, Lord Jesus, help me. I got 3 hours of sleep, and I still know what to do. If I square both sides, that house goes away. I've got 6x plus 1 equals 25. If I subtract 1 from both sides, I've got 6x equals 24. If I divide by 6, I get x equals 4. But you have to plug it back in because there's potential that you can end up making math happen that's not legit. I know just from my brain that this one's going to work out, but it doesn't hurt to plug it back in. So if I were to plug it back in to begin with, 5, you can have another point. Nope, table 5. Okay, I get 3 plus the square root of 25. Does that equal 8? Well, yeah, because 3 plus 5 is 8, so this is legit. 4, you can have a point. 6, you can have a point.
X plus 1 equals 25, since x equals 24, x equals 1.
And then I plugged it back in and checked it. This is me checking. Because I want to make 100. Okay, on the next one, I'm going to add x to both sides. I'm going to write it like that. You can write however you want. 2, you can have a point. Hey, 1, you notice how I keep saving every other number but yours? Oh, sorry, 3, you can have a point.
We love points.
When I square both sides, the house goes away. So I've got 5x plus 4 equals x minus 2 squared.
Yes, ma'am.
And oh my goodness, is a pain in the rear. So let's start over. I moved the x over. I squared both sides, which got rid of the house. And now, sad day, I've got this. I'm actually going to have to FOIL that out. So over here to the side, I'm going to think about it in case you need to as well. Nope. X squared minus 2x plus 4. I get x squared minus 4x plus 4. And you're like, Miss Compton, why do I have to work it out this time? Because we're going to need to combine some like terms. This problem is a pain in the rear. If this was an actual test problem, I would probably just start plugging in the answer choices rather than working it out, if we're being honest. But I digress. Okay, you're like, Miss Compton, you still have a ton of things going on, so I'm going to move everybody to one side or something. I got to do something about my life. So if I subtract 4 from both sides, 4's go away.
Oh, yeah.
So I've got 5x equals x squared minus 4x.
Subtract 5.
If I subtract 5x from both sides,
It would be negative 9x.
I've got 0 equals x squared minus 9x.
Now you gotta square it.
If I take out that GCF of x, I've got an x minus 9. So my two options are x equals 0 and x equals 9. How did you get those two? I did this one equal to 0 and then this one equal to 0. again, you've got to plug it back in and check to see if that's right. Why didn't I just add the 4? It was a minus 4x, and then I subtracted 5x from both sides again. Oh, you're saying why didn't I do? You're right here. You're mad at me. You wanted to do this. Okay. I can see why you do that, but then I only end up getting one answer. But again, Miss Compton's being a dodo this morning. Yeah, you should be getting 2, because it's a squared, I should be getting 2 answers. If I had room or patience, I'd plug it back in. But again, if I saw this problem on semester exam, I was never going to solve it this way. Semester exams and ACTs and all good standardized tests are multiple choice. No one has time for all this, but people do have time to plug in answer choices and figure out which ones are right or wrong. Okay, I want to do 15, which looks like this. Um, 9 and 27. 3 ways to what power is 9? 3 to the what is 9? 3 to the 1, 3 to the 2, 3 to the 3. 3 squared is 9. Table 1, you finally get you a point. 3 to the, you can have another point. 3 cubed is 27. So now they both have the same base. They both have 3's for bases. We discussed on Friday that when we are raising to a power, we have to multiply our exponents. So I've really got 3, and then 2 times 3c is 6c. 2 times 1 is 2, so 6c plus 2. And I've really got 3 times 3c is 9c. 3 times -1 is negative 3. Since they have the same base, I can just set those exponents equal to each other. So 6c plus 2 equals 9c minus 3. I start solving. I end up getting 5/3 equals c.
Go back up a little bit to like the actual problem.
You're good. I'm trying to figure out that.
The girl had to go to the bathroom.
Hey Trey, can you hand me a piece of graph paper? It's underneath all that other paper. It's on the top. Underneath. Yeah. Okay, so if you were here on Friday, what I learned when you were trying to take a math workshop test is that you and logarithms aren't friends, which is a darn shame because they're really not bad. So our next 2 problems, which I didn't write down, so I have to go back to the other thing. Our next couple problems are involving logarithms, and the reason we're going to do them is because I want to show you how you can put it in the calculator. So even if Seth didn't understand, at least he can put it in the calculator and get the right answer. Okay, so I need to write down, I'm sorry, I didn't write them down. Brister, will you answer that? I don't care. That's my name. Yes, she can. Okay, so I know these off the top of my head because I know that 3 to the 4th is 81. I know that 2 to the negative 5 is 1 over 32. This is the kind of thing eventually you will need to know off the top of your head. But for now, since Hunter didn't like logarithms, and he just needs to know the bare basics to survive, if he turned on his calculator, he knows there's a log button, and he's pressed it before, but it's very disappointing. When he presses the log button, he can't put in the tiny number. He wants to put in the tiny 3. How to put in the tiny 3. if he presses math, and then he scrolls down, eventually he sees something that says log, and it says log base, and base is in all caps. So he presses math, he scrolls down, he can find something that says log base. So when Antonia Sweathers didn't teach you this trick, she might not have known it. No big deal, I'm showing you now. So he scrolls to log base, he presses enter, hot dog, now he can finally put in the tiny 3. So log 381, he really does get 4. It's that easy. So on the next one, he presses math, he scrolls down to log base, he does a tiny 2, 1 divided by 32, he gets -5. Hot dog. Suddenly he can do logarithms using his calculator as long as there are no variables. Okay, are there any questions about these?
Would you want me to write it like that and then put the answer?
I don't care. If you just put the answer, then I know you're alive, that's fine. But I mean, if you're studying, would it be helpful to actually have like the question and stuff? Of course. But Hunter, you need to go to the main office. Okay. There are no questions about this? You picked up something on your way in. Let's look at it. Okay, on Friday we were talking about angles. You're like, Miss Compton, how the crap do angles have anything to do with sine, cosine, tangent, cotangent, secant, cosecant? Honestly, we're really not going to get to how they relate. It's got to deal with something called a unit circle. We talked about when you're reading an angle, every table but one, get a point. When you're reading an angle, you actually read counterclockwise. So if you weren't here on Friday, here's the brief. We read counterclockwise. If we were to go all the way around, we would make a circle, which would be 360 degrees, which is why when we start here at 0, if we make it all the way back around, we've gone 360 degrees. So this line is going to be 0 and 360. We discussed 360 divided by 4 was 90, so each little dash is 90, 180, 270, 360. So on Friday we discussed, like, if you were given an angle, let's say it was drawn about here, then we would guess, since that's between 0 and 90 and it's really close to 0, if we were following our maze and it gave us options of like 180, 30, 270, 335, you'd be like, well, duh, that one has to be about 30 degrees. It's between 0 and 90. It's closer to the 0. We're going 30. Seriously, that's what we did on Friday. We talked about how to read it. We also discussed the next couple examples on Friday about what to do if they give you negatives or bigger than 360. So like 375 means they went all the way around and then up a little more. So one way to solve it, every group of one again, get a point. 375 minus 360 is 15 degrees. The 375, its spot is the exact same spot as 15 degrees. So if Natalie goes all the way around, she ends up here. Let's say she goes all the way around and then comes back to here. That's the exact same position as literally just starting at 15 degrees. We also discussed negative ones on Friday. So if you're going negative, it's the same thing as going, yes ma'am.
So all you do is you draw the little thing.
Yes.
And then say like if it gives you 15, you'd only go like this and then stop.
Mm-hmm.
Okay, but then if it gives you like 400, you go all the way around 360.
And then 400 would be 40 more, so you go up to the 40, yes.
Okay.
So, like the 620, you would do 620 minus 360. And then sometimes, so 620 minus 360, let's see. So really it's 260. So 620 and 260 would be in the same spot. So if we were to draw our picture, where 260 is down here, if you went all the way around and then back to there, that's where 620 is.
Okay.
And we discussed to go negative, it's going, which is what Seth said, that's how he got his 1 point of the day.
One
is,
the other way.
yeah, going the other way. So negative 200 would be going this way 200 degrees, which is the same thing as doing what if you went forward? If you went
Clockwise, counterclockwise.
if you went counterclockwise, what degree would it be at? Like negative 200. I drew that really ugly. I gotta.
It'd be past 90, right?
Okay. So I went negative 180. Seth, you're on my nerves today.
Now,
Nothing.
you said nothing, didn't
Yes, I did.
you? What did you say?
I said you're on my nerves.
I'm so sorry.
I know.
Wait, so the first one would be 90, and the second one would be 180, and the third one would be
270.
270.
Yes. And if you know those spots, you can figure out the rest. Okay, so I'm only going to work number 10 because, sorry guys, my brain's not really working today. But negative 200 degrees would be the same thing as going, if I went clockwise, it's the same thing as going counterclockwise 160 degrees. They end up at that same line at the same spot. So I could just do 360 minus 200, and that would help me figure it out. So it's like a clock. So if this is a marking on the clock, I could have gone this way to get to it or this way to get to it. If I went negative 200, I got to this spot on the clock. If I went positive 160, I got to the same spot on the clock. So that's what they're saying when they say coterminal angles. They're just saying, like, if that's a spot on our clock, can you figure it out not with negatives or not being over 360? English fun times. And we discussed that better on Friday when my brain was here.
So if it's a negative, all you have to do is just subtract.
Yes. So, like, to figure out negative 45, if I did 360 minus 45, I would figure out the right answer. So, brain's back on track. God bless you, Kelsey. You can have 2 points for that. If it's a negative, do 360 minus your negative number. If it's higher than 360, just take your number and subtract 360. And then if it's still higher than 360, subtract 360 again. God bless you, Kelsey. Okay, so sad day is that we don't have enough time to really get into what they're useful for, but in pre-cal and from here on out, when you start doing trig, we no longer talk in degrees. Very rarely do we talk in degrees. Instead, we use a different measure of a different measurement, which is called radians. And radian sounds like what word that describes a circle? Radian sounds like radius, and that's where it came from. Oh, Jesus, take the wheel. Absolutely, Jesus, take the wheel. Okay, so if you're wanting to convert between radians and degrees, you're either going to multiply by pi over 180, or you're going to multiply by 180 divided by pi. So radians involves pi, and if you go from 0 all the way around, and you say you've gone 360 degrees, that's the same thing as going 0 all the way around, and radians is going to be 2 pi. Okay, so all Hunter has to do is he's either multiplying by pi divided by 180, or he's multiplying by 180 divided by pi. That's all he has to do to convert. It's one of these two. And you're like, which one do I use when? It just depends. So let's look at the problems. So I'm going to work 2 problems only because Miss Compton's brain is dead today. So, for instance, he's got 120 degrees. He's wanting to go to radians. So he's going to want pi in his answer. So he's going to multiply by pi over 180. So he's got 120 pi divided by 180. He needs to simplify that. If you need to press the frac button in your calculator and make it do it, you can.
Where'd you get the 180?
Half circle is 180 degrees.
Oh, you do half circle because 120 is
Because-
180.
But you do half a circle because if you go the full circle, the full 360, the same as going 2 pi. So going to just 180 is the same thing as going 1 pi.
Okay.
Now, who came up with that? Wasn't me. Was not me. But all you have to know is you're either multiplying by this or this. So I'm multiplying by one of these. It's just which one when. It depends. Am I wanting to go to radians? In this problem, I had degrees. I'm wanting to go to radians, so I do multiply by pi. On this one, I have pi. I'm wanting to go to degrees. I need pi to go away, so I'm going to divide by pi. Okay, 120 divided by 180 reduces to 2 pi over 3. And then in the other problem, it says 3 pi over 8. So I'm going to multiply by 180 divided by pi. Then the pi's will cancel out. And I get 540 over 8. And I don't know what that reduces to. I have to use my calculator. Okay, so this seems stupid. 100% with you. I'm either going to multiply by pi over 180 or 180 over pi. It just depends. Am I wanting to go to answers with pi's or am I wanting to get rid of the pi's? That's how you decide. On this one, we wanted to get rid of the pi's because we wanted our answer in degrees. On this problem, we were given it in degrees. We want the pi's because we want our answer in radians.
Okay, so if you don't have a degree, then you find the degree. But if you have the degree, you don't find the degree.
Right.
Okay.
Right. So if you look at the back, which I'm not doing part of that. If you look at the back, for instance, they give you one that's 5 pi over 6. So I'm wanting to get rid of the pi, so I multiply by 180 over pi, because the pi's will cancel out. But on this one, I need the pi, so I multiply by pi over 180. So either you're doing degrees to radians or radians to degrees. Oh, I don't know the answer to that. That's a good question, Hunter. So 900 divided by 6, which is 150. So 330 pi over 180. Now what's weird? Okay, so with degrees, it's okay if you have a decimal answer, but with radians, they never talk with decimals. They always do fractions. So I was really tempted to put 330 over 180 and put 1.83 pi. You're never going to see the answer like that though, so instead you need to reduce the fraction or turn it back to a fraction. So it's really 11 pi over 6. And if you've forgotten how your calculator does that, if you press math and frac, it can turn your answer back to a fraction. Okay, I know you're not listening to me. I honestly don't blame you. I never said this was going to be an exciting day. We didn't finish our math workshop test on Friday. We don't have enough time today. We will deal with it on Wednesday. Now, Natalie doesn't have to practice this, but she ought to practice this. So on Wednesday, we're also going to have a study guide. But again, the test on this is going to be on Google Classroom. So how she's not going to make 100. And I'm giving her a class on Thursday to